So in this video I'm going to run through the thought processes that I would go through when approaching this particular programming problem, but it would also apply to others. So this is 100 doors. It was quite popular in computing teacher forums, probably in 2022. It reached peak popularity, and I did actually produce a web page to help students visualize what's going on. But we will refer back to the problem as we proceed. There are variations, so there's 100 lockers, for example, and it doesn't really matter whether the doors start off open or closed. But there's a variety of interesting techniques required to solve this. So at various points I'll be asking questions, so if you want to approach this as a student, you could pause the video, have a think about what your answers to those questions would be before you proceed. I'll include links to the original task and my 100 doors page in the description of the video, so you can refer to those yourself. So the idea is that there's 100 doors in a row that are all initially closed in this particular version, and what we're going to do is we're going to visit the doors and we're going to toggle the state. So this is an interesting introduction to the idea of toggling, so swapping the state. So you could also use the computing word there, state. So we can visualize what this looks like. I've created this page here. So there are 100 doors on this page, and in fact you can control how many doors there are, but I'll just do it on the first couple of rows to speed things up. So each door can be open or closed, and by toggling it, what we mean is if it's open, then we close it, and if it's closed, then we open it, and we can do that. So one of the things we need to think about is a mechanism for representing that in our code, which is a kind of abstraction, isn't it? And then what we're going to do is we're going to visit the doors in a particular sequence, and we're going to toggle the position, and then we're going to see which ones are open at the end. And another reason that I like this particular task is that I also teach GCSE maths, and so I touch upon the idea that makes this work in those maths lessons as well. And I'll return, hopefully if I remember, at the end of the video to explain actually what the sequence is that we get, which is actually the last section in last question on the original task there. So just to so you understand what we're doing. So what we're doing, we're visiting every door to begin with, and just double check. So they're initially closed, yes, so they're all in the right position. And what we're going to do is we're going to first of all start at door 1 and visit every one door. So I'm going to go 1, 2. So obviously this takes a little bit of time to begin with. And what you notice about obviously the further you get on in the program, the quicker it is, because the next pass we start at door 2 and visit every second door. So we're going to go 2, 4, 6, 8, 10, and some of the weaker students might also benefit obviously from the mental arithmetic and the times tables, etc. And then we're going to start at door 3 and visit every third door. So already by this point, notice we're visiting some and opening them, and visiting some and closing them. So we're closing 3, but we're opening 6. We're closing 9, but we're opening 12, and so on. So 18, there we go. And then where do we get to? 4. So 4, 8, 12, 16, 20. So as we get further on, we're doing it to fewer doors. So every fifth door from 5. So 5, 10, 15, 20, 6 and 12, 7 and 14, 8 and 16, 9 and 18, 10 and 20. Once you get more than halfway, so in this case past 10, but in the full set past 50, we're only actually visiting one door, because when you visit door 50, you'll visit door 100 as well. But when you visit door 51, obviously the next one will be 52, which is off the end. So then in the second half, we just visit each one. And you might have spotted already which doors remain open, but we'll come back to that at the end. So before I start any programming task, there are some questions or some ideas that you need to think about how you're going to represent or how you're going to store certain things. So what are the key things that we need to think about when approaching this task? So you might want to pause the video now and have a think about that before I start adding them. So for me, the key things you need to think about here are how we're going to represent the state of the door. So how we're going to store the state of the door, if you like. So the state of the door is whether it's open or closed. And so adjust that there. There we go. So how are we going to represent the state of the door? And then also, how are we going to represent, or how are we going to store the full set of doors? So that's an individual door, but what about a full set of doors? So how are we going to store the full set of doors? Because obviously there needs to be 100 of those, and it's not quite as straightforward as you might first imagine, particularly if you're using Python. And step 3, how are we going to choose which ones to visit? So how do we choose which doors to visit? Okay, so those are the key steps, I think, for me for approaching this problem. So how are we going to store the state of the doors? So obviously you could have a discussion with your students about variable types. So what I'm going to do is we're going to get stuck in here. So we're going to need a variable, aren't we, to store each individual door. So what could we call that? We could talk about maintainability, and we could give it a sensible name. So if we called it door, for example, what could it actually store? So if you think about all the different variable types, it could store, a string. So we could store the state of the door as a word. So if we wanted to do that, so what we need to think about, actually, when we think of it, so how are we going to store the state of the door? Probably could have added a bit more there, in such a way that we can easily flip it. And I think that's the key to this, isn't it? So if we stored the state of the door as a string, how would we toggle the state of that door? We could use like an if, couldn't we? So we could say, so if door equals closed equals closed. I've been doing some basic recently, so forget my double equals. If door equals closed, then we'll change it to door equals open. And we could use else here, or I suppose if you wanted to be, it should only be one of those two states, shouldn't it? But if you wanted to be particularly safe about it, I suppose you could check the other state. You could say if it's open, then closed. And then what we're going to do is we'll just print the state at the end. So print door, and we'll see what that looks like. So if I run that now, you can see it started off as closed, and when I get to the end, it printed open. And if I start off in the other position, so if the door is open and I run it, then it tells me it's closed. So that does the job, but that's quite a lot for just effectively a single step, isn't it? So is there a more kind of clever, is there a more computer science way to do it? Well, if we think about what other variable types we've got, you could, I don't think there's any benefit in using a floating point number, but we've got variable and integer as well. So what about if we stored it as something like a Boolean variable? So if we used true or false to indicate whether the door was open or not, would that work? So if we said false, for example, then, or true, depending on what we're going to represent, then that might be easier to toggle. So the problem with that, though, of course, is the name of our variable now. So what does true mean in sense of door? So what we might be better off doing, so if we go back to our original question, they're all initially closed. So what I might do is have a variable, I might call it closed. And so closed true means it's closed. And then depending on what you do, in fact, at the end, I suppose you might think ahead. You might think, actually, what I want to do at the end is check whether they're open. So it might be nicer to call my variable open. But then you might need to be careful because that's also a keyword for opening files, etc. So I'll stick with closed. So how are we going to flip that then? Well, we know our Boolean logic. So over here, so we can do things like, we can say not false, and that will give us true, won't it? So in fact, that's there we go. So if I say not false, for example, it will say true, and if I say not true, it will give me false. So if I just say closed equals not closed. So lots of students to begin with get a bit confused with this kind of idea whether you use the same variable on both sides, because you can't do that in algebra, can you? You can't say x equals 2x, for example, or so on. But you have to remember that what it means is the one on the left is the new value, the one on the right is the old value, isn't it? So the new value of closed is not the old value of closed. So then if we just print that, we'll be able to see what's happened to it. So here, closed is true to begin with, and if I run that, it's now false. And if I just swap that around, I run it again, and so not false is true. So we're flipping that now in a single line. Obviously, we've got an extra line to print it. Is there any other way we could do it? Well, I suppose you could use, if you think about other ways of flipping stuff, this is the next method is particularly good if you haven't just got two states, but you've got something that you want to reverse. So, for example, if you're doing something with a turtle or in Scratch, and you've got a speed, so you've got maybe a speed variable, and it's 10 to begin with, and you can move in steps of 10. If you multiply that value by -1, it flips the sign, but the actual number part, the absolute value, remains the same. So you can reverse direction by multiplying by -1. So we could use that. So again, we won't worry about the name because I'm not going to stick with this. But what we could do there is we could say closed equals closed times -1. So now if closed is 1 to begin with, it becomes -1. But you might know from your maths, if you multiply two negative numbers together, then you get a positive number. So -1 times -1 makes it positive again. So we can also flip or toggle things by multiplying by -1. But I'm going to go with the Boolean logic one. So I'm going to say closed equals, and so they are closed to begin with. So closed equals true, and then we're going to go not closed. Okay, so we don't need to print it at this particular stage. So that's our first question, how we're going to store the state of the door. So think of all the possibilities. Question 2, how are we going to store the full set of doors? So if you've done any kind of Python before, or if you've done other programming languages, you might use an array, but you might be thinking of lists here. So you could have a list of all the doors. The benefit of a list, obviously, is that you can use a loop to process the items in the list one at a time, whereas if you've got 100 separate variables, then you'd have to operate them on them separately. So lists are ideal for processing sets of information like this here. So how are we going to get those numbers into, or not the numbers, the Boolean values, how are we going to get them into a set? So you could say something like this. So you could say doors, and you could create yourself an empty set, and then you could say for n in range 100, and then you could, I'm just going to comment these out. There you go. So you could say doors dot append, and you could, because it's all false, it's all true to begin with, isn't it? So you could put 100 trues in there. So if we run that now, obviously it's not printing anything, but if we have a look at the value of doors, we can see that it's got a load of trues in it. If we want to see if we've got the right number, we could go len doors. Yep, so there's 100 in there. But actually, it turns out that in Python, there's a nice, neat trick that you can do. We can actually multiply things. So if you did false and then just did times 100, then if I run that and we have a look at the value of doors, we can see that it contains lots of falses, and actually getting a bit confused there, aren't I? Because actually this should be true to begin with. So if I run that, we get a load of trues. But if we look at the length of doors, we've got the 100 again. So I said it's not quite as straightforward as that, because we're representing 100 doors. But actually, if you think about the list items or the list indexes for that list, if you've got a list that's 100 items long, they're going to be numbered from 0 to 99. So if you want those to represent doors 1 to 100, you could, apply an offset. You could add 1 to the index to represent the number of the door. But I think there's lots of opportunity for confusion there. So also you might want to think about the trade-off between the additional storage and the additional calculation. So what I propose is just having an extra item in the list so that you've actually got 101 items, and then just not using the first one. If you're using an array in another language like BASIC or JavaScript and so on, you could actually just not use the first element because you don't have to. You can have an element 1 in an array without having an element 0, which you can't do in a list. So I'm going to have 101 items in my list, but I'm going to just ignore the first one. So okay, so that's the second question done. How are we going to store the full set of doors? Then how are we going to choose which doors to visit? So again, that's a sequence, and you might not know off the top of your head how many there are. So you've got a choice here. We know it's going to be repetition, and if you think about your kind of GCSE programming techniques, you've got a choice of count controlled loop or condition controlled loop. So you might not know yourself how many times you want to do this, but we can apply a kind of calculation. We can work out how many times you want to do this. So when we talk about count controlled loops, we don't necessarily mean the number. You say we don't know necessarily that we're going to do this 10 times, but we can perform a calculation. So I would say this was a good use of a count controlled loop. And so what we're going to do is I'm going to call it step, because it's kind of how, it's the step size, isn't it? So you're going to go every 1 and then every 2 and then every 3 and so on. And what step sizes are we going to go through? Well, we need to start at 1 because we need to visit every door initially. And then we're going to go up in just ones. We're going to go 1, 2, 3, 4, up to 100. So remember in Python, when you use range, you can have 1, 2, or 3 arguments. So the first argument is where you're going to start at. So we're going to start at 1 rather than 0. And then the second argument is 1 more than the number you want to go up to. So if we want to go up to 100, we need to put 101 in there. So that's one of those little quirks of Python. So that's the step size. And then we need to visit the doors in order of that step size. So what I'm going to do is I'm going to say for, let's go D for door. I think it's a bit more difficult, isn't it, with loop counters or loop variables to give them a meaningful name, because quite often it is just a counter. So I'll just go for an abbreviation there because I've already used door. I suppose you could go for door as my list is called doors. So for door in range, and which ones we're going to visit? Well, we're going to start at step, aren't we? So the first time, step's going to be 1. So we're going to start at door 1, and we're going to visit every 1 door. And then next time round, the outer loop that starts on line 2, step's going to be 2. So we're going to start at door 2 and go every 2. So if you think about how range works, we can use 3 numbers, can't we? So we can say, where do we want to start? We want to start at step. We're always going to go up to 100, which obviously we need to put 101 there. And the third argument is the step size. So we're going to go up in steps of step. So we're going to go from 1 to 100. First time round, we're going to go from 1 to 100 in steps of 1, and then we're going to go from 2 to 100 in steps of 2, 3 to 100 in steps of 3, and so on. And then what do we need to do? We just need to flip the door, don't we? So we just need to say, we've got the door is our index, so we're going to say doors, door. So door is the item within the list of doors. Is not just the same thing. So we're just flipping that particular door in the way we looked at a minute ago. So what's that going to look like if we do? Is that enough? Well, don't forget you don't have to finish your program before you actually test it. So let's just tell you what we'll do. We'll print doors at the end, and then we'll just see what it's doing. Okay, so I've got confused with my basic again there. So in range, there we go. Okay, so we can see that we've got a mixture of trues and falses. So in my case, actually, the false represents the doors that are open, doesn't it? So because I'm no longer naming it, I'm going to flip the logic of this. So this is a bit confusing, so apologies for that. So I decided that I was going to use true to represent closed because my variable was called closed and I didn't want to call it open because of the keyword for opening a file. But now I'm not using that name, it's just a list element. Then I can flip the logic. So true represents the doors that are still open, and I think that's probably a better way of looking at it now. So if I look at that now, I've got a list that's mostly falses, but there are some trues in there. So now the final part is to think about how we're going to just identify which doors are still open. And so again, what we could just look through them all. So we could say for n in range, so remember we're not using that first list element, so I'm going to start at 1 and 101, and I'm not going to say for n indoors because what I want to know is not the list item, but I need to use the number of it because that represents the number of the door, doesn't it? So I want to have access to the door. If I just said for n indoors, I could have printed whether it was true or false, but I wouldn't know where I was. So I'm going to look through it numerically, and what I'm going to do is I'm just going to say if doors n, so n is just literally just a number. I'm counting up to 100 there. So remember, I don't need equals true because if this part is evaluated, so all ifs are just if true or false. So if doors n means if doors n is equal to true, then we're just going to print. We just want to print the number, don't we? So we're just going to look through and printing all the ones that are true. So if we run that now, okay, so we can see a list of numbers there: 1, 4, 9, 16, 25, 36, 49, etc. So we've done the job. One of the things we haven't got in here is obviously a test case. So sometimes in my programming tasks, I give a test case, and other sites like Advent of Code and things do that, don't they? They give you a little bit of data to begin with, and you can check whether your program works. But I have asked a question at the end here. Can you describe the sequence of numbers that your program has created? So not all students, some of the weaker mathematical students might not recognize this sequence, but this is a sequence of square numbers. So I might always also link this to my mathematical learning. Quite often as I teach GCSE maths and GCSE computer science, sometimes I'll link the two. So we write programs to do things that we're doing in maths, for example. So sometimes you can analyze sequences or produce sequences, or you can check the properties of triangles. I think that's one of the OCR coding challenges. In this case, the idea behind this is, if we just have a look, if you do want to explain this. If you don't, then you can finish there. So if you think about factors, basically, it's to do with factors and how many times you visit the door. So if you think about a number like 12, so if we look at the factors of 12, the factors of 12 are 1, 2, 3, 4, 6, and 12. So students sometimes forget 1 and the number itself. But the thing about factors is they pair up, don't they? So it's 3 times 4, 2 times 6, 1 times 12. Some numbers, if you just go up in sequence, so 13, for example, the factors are only 1 and 13, so that's a prime number, isn't it? It's only got 2 factors. If we skip a little bit more, so 15 is obviously 1, 3, 5, 5, and 15. So again, they pair up, 3 times 5. But what about if we get 16? So if we look at the factors of 16, then they are 1, 2, 4, 8, and 16. So obviously 1 and 16 pair up, and 2 and 8, but 4 pairs with itself. So the number of times you visit the door is basically once for each of the factors, because you visit every 4th door, so you visit in each door that's a multiple of 4. And basically this relies on the mathematical idea that all numbers have an even number of factors because they pair up. So 12 has got 6 factors there, 13's got 2, 15's got 4, apart from square numbers. And square numbers have an odd number of factors because the one that is the square root pairs with itself. So effectively you're losing one. So that's basically how it works. But the key thing there, I quite like this task because it addresses the idea of toggling, which is a kind of key thing. And we can talk about the word state. And then we can also get a bit more use out of range. So we can have a starting number and an ending number. And we can have a starting number, an ending number, and a step.